Let's put that continuity checklist to use by finding the x values where the following are discontinuous. We're going to state why, and that will be using what properties it failed from that continuity checklist, whether it's one or all three. Let's see. So, looking at this first example, to figure out where it's discontinuous, let's just use our algebra method. Let's trace it, and wherever we have to pick up our finger or our pen is where we're discontinuous. So I have to pick up here to draw an open circle, and then draw a dot down here, and then after that I'm good to go again. So the one place where I had to pick up the one x value where that happened is x equals 2. So for discontinuity, we're always referring to x values because that's what we have. Some of discontinuities don't even have a y value, right? If it's a vertical asymptote, it just goes crazy on both sides and doesn't really have a y value. So here, we always talk about x values. So the first x value where I have to pick up, and the only x value where I have to pick up, is at x equals 2. And now we want to say y. So these problems are called proofs. It's where the answer is simple. The work comes from proving why your answer is right. So we know it's right because that's where we picked up our pen, but now we need to prove why. So we're going to prove why by running down our continuity checklist and seeing how many properties we fail. So first thing I want to check is what is f of 2. And one thing I could do is I could use this piecewise function up here, the fact that I know what it's called. If I'm plugging in 2, I have to plug into the bottom because that's where it's greater than or equal to 2. And I can plug it in, but I'm more of a graph person. I'd rather look at the picture. So let's look at the picture x is 2. And the place where it's colored in is going to be our y value, and that y value is 2. So it does have a y value. It does have a colored in piece of the graph. The other thing you could do is you would get the same exact answer if you plugged into the bottom. F of 2 would equal 2. So does it pass or fail that first property? It passes. It has a y value. Y value at x is 2 is 2. So let's check the second piece. Does it have a limit? Limit as x goes to 2, f of x has to exist and really be finite in order to not pick up our pen. And the longer way is, does the left-hand limit equal the right-hand limit? Well, let's check. If we come in from the left of 2, say at x is 1, the graph is up here. And as x is 3, we would hop onto this graph. So our left-hand limit would go up to 6, while our right-hand limit would go down to 2. So do our fingers meet? Definitely not. So that limit does not exist. So does that pass or fail our second property? It fails. The second property says the limit has to exist, and this one does not exist. So we've proven one of the reasons why, but WebAssign asks you for all the reasons why. So let's see if it passes or fails property 3, which says what you found in the first property is the exact same thing as what you found in the second property. So does f of 2 equal the limit as x goes to 2 of f of x? Well, f of 2 from the first property was 2, and the limit as x goes to 2 is d and e. Is 2 the same thing as d and e? No. 2 is only the same thing as 2. So that's not true. So does it pass or fail that third property? It fails. So it's discontinuous at x equals 2, and we would say because it fails properties 2 and 3. Has to fail at least one in order to be discontinuous. This one failed 2. Okay, so let's do that same thing again. We're going to look at a graph. The first thing we're going to do is identify where it's discontinuous, and you can always pause this video and try it on your own as well. So I'm tracing the graph, and I'm good until I get to here. I have to pick up my pencil and circle this open circle and draw this dot down here, and then I hop back on and I'm fine again. So the only place where I have to pick up is at x is 1 to draw the open circle and then put the dot down there. So I'm definitely discontinuous at x equals 1. Always looking at x values where you're discontinuous. And the hard part is figuring out why. So the first thing, this one's called G this time. So I'm going to write G of 1, not a big deal if you accidentally use F, but is technically, its name is G, so we'll call it G. So G of 1, again, I could look up here and plug in to the bottom, and it says it's -3. I'm more of a visual person, so I'd probably look at the graph. Is there a place where it's colored in by 1? X is 1 is colored in down at -3 for the Y value. So does it pass or fail the first property? It passes. Second property says it has to have a limit. So limit as x goes to 1 of g of x. So we're going to follow in from both sides. So from the left of 1, maybe follow in from 0. I get up to 1 in the y value. And from the right of 1, I would hop in up here, go down, and I would get to 1 as well. So does my limit exist? Yeah, it's 1. So does it pass or fail that second property? It passes. Okay, so now I'm getting a little nervous because we said it was discontinuous, and we know it is, but so far, going by our checklist, it looks like it's continuous. So let's look at this last property now. Is what we found in property 1 equal to what we found in property 2? Does the y value equal the limit? Well, let's see. The y value was -3. And the limit was 1. Is -3 the same thing as 1? No. Here's what it failed. All right, we're definitely discontinuous. It doesn't pass that last property. Everything checked out. It had a y value, it had a limit, but then the limit we found was not the same thing as the y value. What was happening near when we found the limit wasn't the same thing that happened at when we found the y value. So it's discontinuous at x equals 1, and we would just say because it fails property 3. Just one of them, but that's enough to say that it's discontinuous.